All right, so we've already talked on the top part there about what trig functions are in terms of like a picture of a coordinate plane, right? This is not necessarily a unit circle because it's not a radius of 1, but if my radius was different, if I had a point that's larger than 1 there, then I would have these ratios for sine, cosine, tangent of y over the radius and x over the radius, and then your tangent is y over x. Now these cosecant, secant, and cotangent, those are the reciprocal functions of that, right? So if I look at this first example here, it says the terminal side of an angle passes through the point -3, -4, and we want to find the 6 trig functions to that angle. So what we're going to do is I'm going to draw where that point is to start in quadrant 3. So we've got the point -3, -4, and that's where my radius is going to go. Again, this is not a unit circle because the radius is not 1. It is larger than that, okay? So if I make this a little triangle here to the x-axis, okay, there's my 90-degree angle. The angle that we are going to find the trig relationships from is going to be the angle that's closest to 0, 0 there, okay? Closest to 0, 0 and in between the x-axis, okay? Not closer to the y-axis. So we're finding this angle. We're not finding from that angle out here. So let's label our side lengths on here. We know that this top part here is -3 and this is -4. Now, if I wanted to find my radius, or that r value I could find by doing Pythagorean theorem, right? Or we know it's a special triangle, 3, 4, what? 5. So we know this side length is 5. And then from there, we can go ahead and write our 6 trig functions, okay? I can write my normal trig functions, and then I can write my reciprocal trig functions. So I've got sine of theta, cosine of theta, and tangent of theta. Okay, sine is opposite over hypotenuse, so opposite from this angle would be -4. Hypotenuse of this triangle is 5, so it'd be -4 over 5. Same thing if you were using this formula up here. Your sine is your y value over your r value. Okay, so our r value is 5 in this case. It's not 1. So -4/5. My cosine, what's going to change my cosine? My answer there. If it's adjacent over hypotenuse, I'm going to have -3 over 5. And then my tangent, opposite over adjacent. So tangent would be -4 over -3, which is equal to 4/3.
How did you get the 5 again?
So I found the 5 by just doing Pythagorean theorem. So 3 squared plus 4 squared is equal to what squared? Yep. Good question. And then if I want all of the reciprocal functions, okay, I'm just going to take and flip these fractions over. So my cosecant of theta is going to be the reciprocal of -4/5, so that'll be -5/4. The reciprocal of cosine is secant, so that would be -5/3. And the reciprocal of tangent is cotangent, so that would be 3/4. Any questions on that? Okey-dokes. Moving on, example 2. Again, using our trig functions, we are going to identify what they are based on these angles that we're given. And this first angle is one of those special cases that we kind of talked about last class. But let's talk about it again. If we have an angle of 90 degrees, angle of 90 degrees would look like this. Okay, it's that angle right there. That's what we're finding. All the trig functions on this angle. Okay, it didn't give us a coordinate point that it went through like this second one does. So we can just say that this goes through the point 0, 1. Okay, you could have said 0, 5, 0, 10. Okay, they're still going to give you the same answers technically regardless. Okay, so if I am finding my sine, cosine, and tangent of this, we have my x and we have my y, right? To find my r is technically, it's that Pythagorean theorem. If I look back up here, your formula for r is technically the square root of x squared plus y squared. So if I plugged in my values, I'd have the square root of 0 plus 1. So that means my r value is also 1. Okay, so sine is your y value over your r value. So my y value is 1 over 1, which is going to give me 1. Cosine is my x value over that r value. So cosine would be 0 over 1, which would equal, is that 0 or undefined? 0. And then tangent is my y value over my x value. So I have 1 divided by 0, and 1 divided by 0 is undefined. Okay, now if I was finding the reciprocal of these functions, the reciprocal of sine is cosecant, which would give me 1. What is the secant of theta going to give me? What's the reciprocal of 0? Undefined. And then the reciprocal of tangent, or the reciprocal of undefined, is going to give me 0. Okay, now letter B, we're going through a certain point. We're going through the point -3, 0. So -3, 0 is going to be on the y-axis, or sorry, the x-axis there. It's going to look something like that. That's the angle we are looking at -3, 0. Okay, now if I was doing my r value for this one, it's easier when there's an actual triangle you can see. If you can't actually see the triangle, though, we just take the square root of both of those things squared. Well, if I take the square root of -3 squared, that's 9 plus 0. What is my r value going to be in this case? 3. And now I can just go ahead and write out my 6 trig functions. I've got sine, cosine, tangent. So my sine value is my y value divided by r. So 0 divided by 3 is going to give me 0. Cosine is my x value over my r value. So that's going to be -3 over 3, which is -1. And then tangent would be my sine value over my cosine value. Or technically, your y value over your x value. So this is the same thing as 0 over -3, which still gives me 0, right? And then we can go ahead and rewrite our reciprocal functions. So I'm just going to flip these fractions upside down. What's the reciprocal of 0 going to give me? Undefined. The reciprocal of -1 is just going to be -1. And again, the reciprocal of 0 is undefined. Okay, so the difference between ones like these and the ones that we were doing is that this radius is now not 1 anymore, okay? It could be anything else. We have to find out what the radius is in order to set up our ratios, okay? All right, reciprocal identities. These are basically just things that are proven to be true, okay? Like if I was trying to find cosecant, cosecant is technically 1 over your sine value. Your sine is 1 over your cosecant. They're reciprocals of each other. So if you're trying to find the other one, take 1 over it, and then you'll get the answer. But if you're given certain things, we can find the others, right? So like if I tell you that secant of theta is 5/3, but I want to find the cosine of theta, we just really need to know what is 1 over secant, right? Because that's the formula there for cosine. So cosine of theta is using this formula right here of 1 over secant of theta. Well, what's 1 divided by 5/3? The reciprocal of 5/3 is 3/5. So if cosine is 3/5, then secant would be 5/3, vice versa. If you're given secant is 5/3, then cosine is 3/5. They are reciprocals of each other. Okay, this next one we're trying to find sine if we know that the cosecant is negative square root of 12 over 2. Well, sine of theta is this formula right there. Sine of theta is just 1 over my cosecant. Okay, they are reciprocals of each other. So if I plug in this value, 1 over the negative square root of 12 over 2, that's going to end up giving me what? Negative 2 over the square root of 12. Okay, and if you guys remember last time I said if there's square roots in the denominator, we're not going to rationalize it. However, what is the only thing that we are going to do with square roots? Simplify it if we can. Okay, so we can simplify the square root of 12. The square root of 12 simplifies into the square root of 4 and the square root of 3, right? So I could rewrite this as negative 2 over 2 square root of 3. Are we okay with that? And then my 2's cancel out. And so I'm left with just negative 1 over the square root of 3. I do not need to rationalize it. We can leave our answer like that. Okay, next thing we are doing is we are going to identify what quadrant the angle is satisfying these conditions that we're given. So I want to know, when is the sine going to be positive, greater than 0, and when is tangent going to be less than 0. So there's a nice little acronym that you can use to help you figure this out. And you can come up with your own if you'd like, as long as it's school appropriate, or just don't tell me. Okay? And that acronym is all students take calculus. Which is actually obviously not true, but it is an acronym that will help us remember where our things are positive. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. You can also just write 1, 2, 3, 4. It doesn't have to be in Roman numerals if you don't want to, okay? Now, how this works is I would label this kind of picture where all trig functions are positive. Okay, so in my first quadrant, all of them are positive. Sine, cosine, tangent, and then all of the reciprocal functions will be positive. Okay, the S is going to stand for my sine function. So all of your sine and the reciprocal of sine, which is cosecant. So sine of theta and cosecant of theta are going to be positive. T is going to stand for, what do we think? Tangent. So tangent of theta and its reciprocal, cotangent of theta. And then my C value, that's going to be my cosine and my secant. Okay, so my original trig function is what that ASTC stands for, and then your reciprocal function is also going to be that same positive value in that case. Okay, so if you want to come up with a different acronym to help you remember, but ASTC is where you need to remember that those things go. Okay, so if I look at this first example here, it says that sine of theta is greater than 0. So where is sine positive? Where is sine bigger than 0? Which two quadrants? 1 and 2. Okay, so this is in quadrants 1 and in quadrants 2. Now the second one says tangent is less than 0. So we're looking at where is tangent negative. Okay, this graph shows us where it's positive. So it's positive in quadrant 3 and quadrant 1. So where is it going to be negative? 2 and 4. So 2 and 4. So that means I want one that's going to satisfy both of those. So my answer for this problem is going to be in quadrant 2. because it satisfies both conditions. Okay, the second one says cosine of theta is less than 0. So I know cosine is positive in what two quadrants in my picture here? Cosine is positive where? Quadrants 1 and 4 is where it's positive. So I want to know where is it negative. It's negative in the other two quadrants. So it's negative in quadrant 2 and quadrant 3. Where is secant of theta less than 0? Well, how does secant and cosine relate? How are secant and cosine related? They're reciprocals of each other, right? So wouldn't this just have the exact same thing? 2 and 3. Okay. So my answer would be 2 and 3. Quadrants 2 and 3 are where those both occur. Okay, this middle section here is going to make more sense when we actually graph these trig functions. But for right now, you can cross out this middle section. And then basically what I want you to do is be able to read this chart and be able to answer these questions, okay? So what it's saying is it's saying that your sine and cosine trig functions can only have values in between -1 and 1, okay? It can include -1 and it can include 1, but it has to be in between those in order for it to be possible, okay? Tangent and cotangent have to be anything. They can be any real number. So anytime you see tangent of a number, cotangent of a number, you can always just say possible for that. And then my reciprocal functions of secant and cosecant, those have to be in between -infinity and -1, and then 1 and infinity. Okay, so it cannot be in between -1 and 1. So using this chart, again, it'll make more sense once we actually graph these functions. But right now, if I use this chart and I answer these questions, sine of theta is equal to the square root of 3. I need to see, is that going to even be possible? Well, square root of 3 is approximately like 1.7, okay? It's not quite 2, but it's a little bit more than 1. So if I look at my sine thing right here, is that possible? No. That one's larger than 1, right? So you can just say impossible. All right, tangent of theta. Tangent of theta, 110. Is that a possibility? You betcha. So this is possible. And then secant of theta is 0.6. Is 0.6 in that interval? No. So this is impossible. Okay, in this Pythagorean identities, I want you to change, this is a typo, this where it says tan should actually say cotangent squared of theta. I'm just going to cross out the whole thing, okay? Otherwise, that wouldn't quite make sense that I have two things equaling different stuff. Okay. So I'll come back to the Pythagorean identities, but looking at the quotient identities, we've talked about cosine and sine and how they relate to tangent before. So tangent is just your ratio of sine values and cosine values. Cotangent is cosine and sine values. So if I am given that tangent of theta is equal to 4/3 and it's in the third quadrant, I need to find both cosine and sine. So if I were to go ahead and graph this, I've got in the third quadrant, I'm going to have a line there. I've got my triangle. I know this is my theta value. I need to put where that 4 and that 3 make sense in terms of tangent. Tangent of theta is equal to 4/3. So where would 4 be? Is it the short side, the long side, or the hypotenuse? If it's opposite over adjacent from that angle. 4 is that long side, right? So this would be 4. And then 3 is my adjacent, so is that going to be my short side or my hypotenuse? My short side, okay? Now, it says it's in quadrant 3, so if it's in quadrant 3 over here, these values are both also going to have to be negative, right? Okay, and now this is a nice 3, 4, 5 triangle. I can find out my radius there is 5, or my r value is 5, and now I just need to go ahead and identify my cosine value of theta and my sine value of theta. So cosine is going to be your adjacent over your hypotenuse. So what's my ratio going to be for cosine? negative 3 over 5. And then sine is opposite over hypotenuse, so that would be negative 4 over 5. Now, why was my hypotenuse positive instead of negative? Because it's not a coordinate and I'm squaring it, right? If I do negative 4 squared plus negative 3 squared and then take the square root of that, I'm going to get a positive answer. Okay, so good thing there. All right, and then the last thing, I'm just going to kind of show you how this Pythagorean identity came to be about, and that'll be it for the day. We're not going to really use them much, though, in your homework today, but I just want to kind of show you how it works. So I'm going to just rewrite the, what am I trying to say? The triangle formula for Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. Okay, in terms of what we're talking about with this unit circle stuff, we've been saying x squared plus your y squared is equal to your radius squared. Okay. Now, this Pythagorean identity has it equal to 1. So if I wanted to get this thing equal to 1, how would I get rid of that r squared? What would I have to do to make that equal 1? That would be giving me r. I want it to be 1. So how would I make that 1? What do I have to divide by? If it was 10 and I wanted to make it 1, how would I make it 1 from 10? Divide by 10, right? So I'm just going to divide all of this stuff by r squared. Okay, that goes away. I'm left with x squared over r squared plus y squared over r squared, and that's equal to 1. Now, do you guys agree that I could rewrite this as x over r squared plus y over r squared is equal to 1? Yes? And then lastly, there was one on the previous, maybe 2 pages before, x over r and y over r stand for something. A trig function. What trig function is x over r? Cosine. So I could rewrite this as cosine of theta squared plus, this is sine of theta squared, and that equals 1. Okay, the only difference between what that is written there and what is written right above in that box is that the 2 is in a slightly different place. So I could rewrite this as cosine squared theta plus sine squared of theta, and that equals 1. Now, if I did not have my parentheses here around the cosine of theta and I put the squared term there, technically that would be like squaring just the theta. So you do need parentheses there, or you need to write it like this, okay? Now, you can find out the other identities by doing the exact same process. Instead of dividing by r squared, you can divide by x squared and y squared to get those other things as well. So we'll be using a lot of these identities to be able to kind of manipulate some equations and solve for some things. But that is it for notes. Your homework is posted on Schoology. Answer key is posted as well. I don't think it's terribly long. I don't remember how many total questions, but...
Some deciding questions start at now or give my brain break.
Oh, that's fair. That's fair. But there are quite a few of them that you're literally just going to answer impossible, possible, impossible. So they're not going to take a ton of time, I should say. Okay. Let me know if you have questions. Otherwise, work time is yours. You got about 25 minutes or so.